All right, so today we're taking a look at 8.4, rational expressions. You can use much of what we already know about multiplying and dividing fractions to multiply and divide rational expressions. We're going to be looking to not only just, in this case, talk about multiplying and dividing those fractions, but you're also going to think about, because rational expressions include polynomials, you're going to want to simplify these polynomials, whether that be through factoring or other means. And then what you can do is cancel some things out in the top and the bottom, the numerator, denominator, and then you're going to simplify it down and see what you end up with. And a lot of times that works for both multiplying and dividing. You simplify first, then you conduct the rest of your actions. One of the big things we also want to make sure here is that we are continuously watching out for restrictions in the denominator, or values that cannot be in the denominator, or else it ends up being undefined. So if you have an x in the denominator, x can't be 0. If there's a y, y can't be 0, depending on the circumstances. So just keep those things in mind, very important. By definition, a rational expression, like I said, is the quotient of two polynomials. So here we're looking at our first example that says simplify. So these are simplifying rational expressions. We're just going to start with question 1, and we're going to try to simplify this. In this case, we should see that we can simplify some things here. We know our division rules for exponents here. So if we're going to go ahead and simplify this, 3 minus 2 gives us 1y. We'll do the same thing for the x's, 2 minus 3. In this case, we're going to see that it's negative 1, so we'll put the x on the bottom. And then 24 divided by negative 6 is just going to be, in this case, negative 4. So in this case, this is our simplified form. But we did mention talking about things that cannot be in the denominator or watching out for restrictions. When we go to base our restrictions, we're going to base them off of the original expression here. Notice here that x and y are both in the denominator. So in both cases, neither of these variables, because of how they're set up, can be set equal to 0. So we want to make sure that we include that. X cannot be equal to 0. Y cannot be equal to 0. So go ahead and fix this rectangle. And so this is our answer. Question 2, we're dealing with two trinomials here. So to simplify this, it's actually in our best interest to go ahead and factor these to see what happens on the top and the bottom. So if we factor these, and I can factor these pretty quick, factors of negative 8 that add up to be 2, well that's going to be 4, x plus 4, x minus 2. On the bottom, we have factors of 6 that add up to be negative 5, well that's going to be negative 2, that's negative 2, and negative 3. So as we go to simplify these, we should see that these two quantities are the same, so they'll cancel. And so what we're left with for our final answer is x plus 4 over x minus 3. But once again, we have to look for those restrictions. And in this case, if we're looking at the original expression here, we've got minus 2 and plus 3. Or sorry, minus 2 and minus 3. So in this case, x can be neither a positive 2, or this becomes 0, and x can also not be a 3, or else this becomes 0. So x cannot be equal to 2, and x cannot be equal to 3. All right, question 3, same idea. We've got a polynomial on top, a polynomial on bottom. Let's see what we can do to kind of simplify this. In the top, I know that I can factor out a GCF. The greatest common factor would be 4 here. So I'll pull out the 4. I've got 3 minus x. On the bottom, I know that this is the difference of squares, so this gives me x minus 3. Oops, that's not on, right? X plus 3. And right off the bat, it kind of looks like nothing really cancels, but what we could do is take out instead a negative 4 up top here, which would make this 3 negative. This would become a plus, a positive x. And so what the top really looks like now is negative 4. Let's rewrite this with the x in front, minus 3. And then you've got x minus 3 on the bottom, x plus 3. So now we're starting to see things that could cancel. Like we've got the x minus 3, the x minus 3, those cancel out. And so now we're left with negative 4 over x plus 3. And we've simplified this. But now we need to look for our restrictions. And in this case, we have x minus 3, x plus 3. So that means x cannot be equal to 3 or negative 3 in this case. All right, so in the next set, we're going to look at multiplying. And we know normally with fractions, you multiply straight across. But to make life a lot easier here, we're going to try to simplify before we multiply, because otherwise these are going to be really large. So let's just start with question 4. I'm going to go ahead and start by simplifying this piece here. So this would be x plus 3, x minus 2. In this case, x minus 5 is on the bottom. Then I'll factor this portion here, the difference of squares again. We've got x minus 5, x plus 5. And on the bottom, we've got x plus 3, x plus 1. Remember, when you simplify fractions, you can also, if they're being multiplied together, you can cancel out diagonally as well. So in this case, we should be able to cancel out this x minus 5 with 1 here, and then this x plus 3 with this one here. Okay, this makes this a lot easier for us to deal with right now. And so as we multiply across, we don't actually have to FOIL anything out. We're just going to take what's there. So we've got x minus 2 would multiply by x plus 5. And on the bottom, this is just a 1 times x plus 1, so this is what we have on the bottom. And so this is our answer. And so we need to figure out our restrictions, and in order to do that, we're not going to look at just this bottom one, we're going to look at these. What can't x be in this case? In this case, it can't be, x cannot be 5, it can't be negative 3, and it can't be negative 1. And I'm going to write them out fully. I like it better that way. So x can't equal negative 1, and x cannot equal negative 3. So this is our answer. So now we're going to take a look at question 5. All right. That way we have more room. So question 5, same idea. Let's just start simplifying what we have. We'll start with this part here. 2x minus 8. We can take a 2 out. It may help, may not. We'll see. On the bottom, we have the difference of squares. So this is x plus 4, x minus 4. And then here we've got x squared plus 5x plus 4. That's going to be x plus 4, x plus 1. On the bottom, two numbers that multiply to be 6 but add to be 8. There aren't any. That's non-factorable, so we'll just leave this alone for now. And so now we're going to have to cancel what we can. So here, the x minus 4 cancels here like we would normally, but then we're going to look diagonally to cancel within the multiplication, so we'll cancel those two. And so what we have left is the 2, the x plus 1, and this trinomial here. So we'll just go ahead and multiply this out. So our answer in this case is going to be 2 times x plus 1 over x squared plus 8x plus 6. And then in this case, we got to keep in mind our restrictions. So it's going to be x cannot equal 4, x cannot equal negative 4, but x can also not equal any of the zeros for this quantity. And we don't know what those are right now. We could use the quadratic formula, but we're just going to say, we'll just say the zeros of x squared plus 8x plus 6. All right, in the next problem, we're talking about dividing. And dividing is almost identical to multiplying, except you have to remember your fraction division rules. When you have two fractions that are dividing, you'll flip the one on the right and turn it into multiplication. And that's essentially what we're going to do here. So instead of dealing with question 6 as division, we're going to go ahead and change this into multiplication. So 2 minus x over x squared plus 2x plus 1 times x squared minus 1 over x squared plus 3x minus 10. So now that we have this, we can simplify things. So we'll just kind of see what's here. I'm going to change this particular problem. I don't like the way this is written. In order to get the x in front and have it make a little bit more sense, I'm going to pull out a negative 1, which is going to make the x positive, and then make the 2 negative. So it looks like this. On the bottom, I can factor this. This is x plus 1, x plus 1. On the other side, difference of squared, so squares, x minus 1. And then here, you've got negative 10 adds up to be a positive 3. Well, that's going to be positive 5 and negative 2. So now we just need to see what cancels. Well, x minus 2, and positive 1, positive 1. And so we have the negative 1, the x minus 1, the x plus 1, and the x plus 5 left over. So that means our answer looks like this. Negative 1 times x minus 1 over x plus 1, x plus 5. So in this particular problem, it's a little trickier to find your restrictions. You can kind of think of it the same way we have the other ones, I guess, in this regard. Well, let's see, change the color on the pen. So ideally, we normally look at this range here, and for the most part, we can get our restrictions from that as well. Like, in this case, I know x cannot equal 1, x cannot equal negative 5, and x cannot equal 2. But there's actually one missing in this case. If you go back to the original expression, this is x squared minus 1, which we know is x plus 1, x minus 1. This expression has to be true in the very beginning for us to even get to the end. So we also have to account for, and actually this should be negative 1, sorry, there. So we also have to account for both of these, like x cannot equal 1 here and negative 1. So we need to also add in here x cannot equal 1. To account for both. We're going from the original and the final to find all of our possible restrictions for this problem. So this is what we get. So we have our simplified form, and then we have all of our restrictions because of that. All right, let's take a look at 7. So 7, we've got all of this work here. I'm going to cross this out. We don't need this. So it gives me more space. So question 7, same idea. We're going to change this into multiplication first, just to make life a little easier on us. So we're going to go over here. So we're going to get x squared plus 5x plus 4 over x squared minus x minus 12 times, in this case, 2x squared minus 6x over x squared minus 1. All right, so with that, we can now start simplifying. So on the top, I've got x plus 4, x plus 1. On the bottom, I've got x minus 4, x plus 3. On the other side, I'm going to factor out a 2x. So 2x leaves behind x minus 3. Over here, I've got x minus 1, x plus 1. And so now I just need to simplify. So let's see. Oh, I see I made a mistake. This should be x squared plus x, so that changes the values here. So let's change this real fast before we start simplifying anything. This should be minus 3, this should be plus 4. Now that looks better. I was wondering what was up there, but this looks better now. All right, so now cancel out the fractional pieces. We'll cancel out multiplication diagonally. We can see that this piece cancels as well with this piece here. And so we're left behind the 2x, the x minus 1, and then here we have 1 and 1 essentially. And so our final answer here, in terms of what we have, is just 2x over x minus 1. And then we just need to account for our restrictions. So x cannot equal, in this case, negative 4. X cannot equal 3. X cannot equal 1. And x cannot equal negative 1. So we're going to put those together. But we're missing 1. And so, like the last problem, the original expression that was on the bottom on the right side was 2x squared minus 6x, which we know to factor to 2x and then x minus 3. Well, we have the 3 accounted for here, but this 2x means that x cannot equal 0. So we have to include that in our answer as well. So we have to include the fact that x can also not equal 0. And so this is our answer.